Gears by Vincent Fazio, Dalal, Gryniuk, and Logan Tracy. Oxford defines a gear as one of a set of toothed wheels that work together to alter the relation between the speed of a driving mechanism and the speed of the driven parts.
The first recorded usage of a gear was in the 27th century BC China, where a gear would counteract the rotation of the wheels of a chariot to maintain a direction set by a pointer compass on top. This allowed them to keep a direction, preferably south for them, without the use of magnets and a normal compass. Centuries later, the Greek philosopher Aristotle gave the first academic description of a gear, such as a device that would reverse the direction of a rotation of another gear wheel. The ancient Greeks went on to use the gear to build clocks and water wheels, devices allowing them to transfer mechanical energy from rivers to other devices such as mills. The most important discovery about gears is that different combinations could be used to generate different amounts of power, such as the transmission of an automobile or the gear changer on a bicycle.
Shown here, we have an SEM image of a gear.
Over the years, many different situations have called for the use of many different materials in the manufacturing process of gears. The material used directly relates to whatever the largest concern is, whether that be the durability, strength, or cost.
Future compositions of gears might include stronger polymers, polymers mixed with metal gears. Heat treatments are also an option as well. You take current existing materials for gears and you put them under heat treatment. That improves the state of the gear with strength and torsion. Also, future compounds might be discovered, like new metal alloys or ceramics that offer a higher quality of steel gear.
To begin, there are many core necessities for gear material. They must be made of high tensile strength, high endurance, low friction coefficient, and have the ability to be manufactured. There are an endless amount of possibilities to create gears, including brass, bronze, plastic, and cast iron, but we chose to focus on steel for its many applications in today's day and age. Some day-to-day objects include parts of a car, dishwasher, elevators, cutlery, and nearly any stainless steel object. Stainless steel is an alloy of steel that is ideal for food production, storage, and sterilization. It's corrosion resistant, which is crucial to long-term use and even aesthetics.
The history of steel can be traced back 4,000 years to the beginning of the Iron Age, when it replaced many tools and weaponry as opposed to the bronze that was traditionally used. In 1856, Henry Bessemer produced an efficient manufacturing process to reduce the carbon content in iron. In the 1860s, German engineer Carl Siemens further enhanced steel production with the open hearth process.
There are three main steps in the method of production of steel. The first part is getting the iron from iron making. Iron is a huge component in all steel compounds. The second step is when you actually make the steel. This is when you take your compounds, whatever percentage of materials you have in the steel are compressed into its element of actual steel. And then the third element is whatever you need it for. An example of it is rolling. This is when you roll steel into flat sheets and it's easy to ship and has a lot of applications.
The applications of steel can be divided into 5 unequal sectors: construction, transport, means of energy, packing, appliances, and industry. One of the most notable usages of steel is the previously mentioned alloy, stainless steel. Stainless steel is used in the medical industry such as surgical supplies, instruments for sterilization, surgical implants, and those are just to name a few. In terms of construction, sustainable steel structures can be quickly built at a low pricing and be reformed to match criteria for applications. Around half of all steel produced goes into the construction sector.
Steel has had a massive commercial impact in the United States. In the United States, iron and steel industry generates about $520 billion in the U.S. economy, as steel is one of the most used materials in the world. The industry also generates over 2 million jobs, making up a large 1.5% of the job market.
There are many special and weird characteristics to steel, one of which is that it is roughly 1,000 times stronger than iron. Steel is also the material used in delivering renewable energy. Steel roofs last longer than 50 years compared to the normal 17 years of most other roofing materials, and 75% of all major appliances are comprised of steel in some way.